Hello, my name is Boy van Dijk. I'm a streaming solutions engineer at Unified Streaming, and today I want to talk to you about optimizing MP4. Optimizing it in particular for setups that combine a just-in-time packager with remote storage. One like you can see here that runs in AWS or any other cloud. In this particular case, we have remote storage on S3 and we have a CDN in between the just-in-time packager and the customers that caches the most popular content. Remote storage is popular for various reasons. One of them being that it's relatively cheap. Another one is that it has a very high throughput and also basically offers infinite storage. One downside, however, is the latency, especially if you compare it to a local set of SSDs, for example. And once this latency starts adding up, that's when it also starts affecting the startup latency. And the startup latency is basically the difference between pressing play on a stream and a stream actually starting to play. In order to present to you the solution of how to work around this latency, I need to focus on a specific box inside an MP4. The box that stores the index of the MP4. The index tells you where all the media data in the file is located. For progressive MP4, this index is located in the moov, and for a fragmented MP4, it's located in the MF array or SIDX, and they tend to be at the start or the end of the file. So why is this index so important? This is especially true in setups that run a just-in-time packager, because a just-in-time packager needs to fetch the media data from the source, but first needs to know where the media data is. And so every time it needs to get any media data from the source, it needs to first read the index. And so in order to do that, Unified Origin reads the first bit of a file and the last bit of the file before it actually can retrieve the media data that it needs. And yes, this is particular to Unified Origin, which is a just-in-time packager developed by Unified Streaming, but I hope it's informative for other packagers as well, in the sense that it shows that there's additional requests to be made to your storage backend before you can actually get the data that you really need. And so what this teaches us is that when you work with remote storage, when you have the latency introduced, here, when we fetch a media segment, the latency will triple because we make 3 requests to serve 1 request from a customer. Another important thing to note here is then when we want to run very large scale deployments, when we want to serve a very big audience, we probably want our just-in-time packager to be stateless, because that scales the best. And so that means that every request that hits your just-in-time packager, it needs to fetch all of the media data, all of the metadata, all of that again, even though an earlier request that came in actually required the exact same information. And this in particular affects your Longtail. Your most popular content, as said already, that can be cached on the CDN, but you can't cache everything. That will be too expensive. Then you wouldn't need a just-in-time packager or remote storage anyways. It's the Longtail content that's actually the biggest part of your video library, but that gets the least amount of requests. Let's say that it consists of 80% of your library, but it only gets 20% of the requests. Now, the solution that I'm presenting to you here is there to optimize the delivery of Longtail content, so that if one of your customers want to watch a less popular movie, they can still assume that the stream will start playing quickly. And what's the solution here? Well, it's clever caching. Clever caching in between the remote storage and your just-in-time packager. And what's so clever about it? Well, that's the format that is used. When it's simply caching the media data, we're caching dref MP4s. And so what's a dref MP4? Well, dref stands for data reference. And dref is actually also a box inside an MP4. This is a completely spec compliant approach to MP4. So in specific, a dref MP4 points to the media data in a source file and contains the metadata of that source file. This means that it's very lightweight and therefore easy to cache. And by caching it, we actually bring the metadata that the just-in-time packager needs to fulfill almost any requests. We bring that metadata closer to the just-in-time packager. In that way, the dref MP4 serves a bit like a middleman in between the just-in-time packager and the remote source. And by serving as a middleman, it helps the just-in-time packager cut down on the number of requests that need to go all the way to the remote storage. And one thing to note here is that a dref MP4 is really small. If you look at a movie of several gigabytes, your dref MP4 will probably be tens of megabytes, which is many orders of magnitude smaller. Another thing to stress here is that dref MP4s are not tied to any particular caching solution. You can basically run the caching solution that best fits your needs, and of course that aligns well with your just-in-time packager of choice. Also good to know is that because the just-in-time packager still relies on the media data from the actual source, you can rely on your just-in-time packager to be able to serve out all of the formats that it was able to serve out before. And also it should still be able to add encryption and DRM and all the bells and whistles that it supported. Okay, let's take a look at how much benefit this approach will actually bring you. I ran a couple of tests in AWS. I had one setup with caching and one without. The one with caching, I had the dref MP4s locally cached on the origin to simplify the whole setup. So the differences here are a little bit more dramatic, but still informative, I believe. If we look at the MPD, the difference is very stark. Without the caching, it takes almost a second to generate. And that's because the just-in-time packager needs to read the timelines, need to read the indexes of all of the different tracks, because timelines of all of the different tracks are represented in the MPD. When the dref MP4 is locally cached, it takes only 16 milliseconds. When we look at the init segment, the difference is less strong, but still considerable. And when we look at the media segment, the difference is relatively small. And that's because for the media segment, the just-in-time packager will actually fetch the media from the remote source. And so the latency will not play that big of a part anymore, because it's true for both cases, with or without dref caching. Also, additional research has shown us that, at least with Unified Origin, using dref MP4 caching gives you a much higher throughput on the just-in-time packager. We saw improvements of 10 to 20%. And so that's the entire dref MP4 caching setup that will bring down the startup latency of your long-tail content for your customers, and also improve the overall efficiency of your just-in-time packager setup when you combine it with remote storage. All by bringing the boxes and the information inside it that just-in-time packager needs most often much closer to the just-in-time packager. But that's not everything that dref MP4s can be used for. I want to point out 3 other quite unrelated but still very interesting use cases. The first being also the first that we use dref MP4s for at Unified Streaming, which is the on-the-fly conversion of fragmented MP4 to progressive MP4. For example, to cater to older smart TVs that don't handle HTTP streaming standards well. Another example is the on-the-fly stitching of content, where you need to build a new timeline. You can store that timeline in the dref MP4, such that the just-in-time packager can read the dref MP4 read the timeline, and fetch the media data from the different sources and produce as its output a seamless stream. And finally, there's a use case of adding or interleaving type metadata into on-demand content. You might have a very, very big on-demand content library, and you might want to add Scotty35 markers to it in order to support dynamic ad insertion. Well, of course, you can repackage all of that content, but that takes quite a while. What you can also do, create dref MP4s, store the Scotty markers inside those dref MP4s, and have the just-in-time package to read the dref MP4s, thereby reading the Scotty markers and fetch the source content to which the dref MP4s point. And then the just-in-time packager can wrap up all of that information and produce output that is compatible with dynamic ad insertion services. And that's about all I know, at least, about dref MP4s. I hope you found it interesting. If you have any more questions, please feel free to ask. There's more information about this approach in our documentation as well at docs.unified-streaming.com. Of course, it's tied to Unified Origin, but might still be interesting if you're not using Unified Origin, just to see how the approach works. If you're at documentation, just search for object storage reducing latency. And also we have a scientific presentation available about this approach that uses dref MP4 caching at tinyurl.com/dref MP4. Thank you for listening and enjoy the rest of Demuxed.